Hi, Helen, how are you?
Good, how are you?
I'm okay. Are you doing okay so far?
Yeah.
This year you have the CSA and CSP exam. Do you have others?
I have AP pre-calc, but
Pre-calculus. That's okay. That's an easy one.
yeah.
So far, are you okay for this CSA and CSP so far?
Yeah, I'm good.
Do you need some sort of help in the CSP project?
Oh no, I don't. We're just doing code.org, so it's not like
I know,
very.
but did you finish it already or no?
Our class is gonna start it this week.
For the project?
We did like a practice project last week, and this week we're gonna do.
Okay. Let me know if you want me to do proofreading, okay?
Okay, thank you so much.
Okay, we also have Elaine and Xavier. Okay, let's get started. Okay, we already 8 o'clock. We don't wait for people. So people who don't want to join, I don't care. Okay. Okay, anyway, we go to the question 13. Okay, we started from question 13 today, and then last time we have finished the 12. So let's go 13. So 13, let me get started with Elaine, okay, from top this time. So 13, we have ticket, we have transaction. And then 13 is here, which can replace the more code. Okay. So let's look at the more code right now. The more code is you do have a for loop, and you are going to read for the seat, row, and price. And then you are going to set up your ticket. Okay. So what will you do? Which one is correct?
Um, for this one, I think B would be the best answer because A, and C, you don't need the parentheses after. I mean, sorry, you don't use like get row. You use like
You pick
the
B,
row,
right?
right?
You pick B.
Yeah.
So C, D, E are wrong because you do list. You're not new ticket, right?
Yeah.
So this you can so this one you have the get row and the number. Okay, get row and number. Which one you would do? Actually, let's look at it. So for ticket, they are get row, but get row you need to have an object to get row, right? But this one you are doing a you have the transaction. You have a number right here. You have this different the row, the seat, and the price. So you're using these three numbers to set up. You are actually not, you actually, when you get row and get seat, you do get row, get seat, and get getting function. This one you do need to have some ticket that get row. It's actually, these are the function for the ticket. Okay, so this cannot do. So actually, yes, is B, right? Actually correct. So this one for 14, let me have Helen.
For this one, I said C.
This one is says C. So basically, if you list T is wrong, right? You actually need to get from ticket list. So these two
Right.
should drop. And then your T list to get price is wrong. T get price is okay, but Peter price is private, so it's wrong. So actually you can only do C. Okay, this one okay. Number 15. Xavier, number 15.
A.
It's necessary to keep these all ticket transactions, assuming that they are so many transactions. So ticket to transaction are wrong. Okay. Transaction to ticket wrong. This is also wrong. So actually only a yes. Okay. Okay, we have Banani just joined. Okay. Anyway, let's go back to Elaine number 16. Hi, Banani, how are you? Number 16, here you have precondition, some loop, and then it's a 1, 2, 3 problem, and then look like there's something wrong. Okay, there's something wrong in the program. So here's something wrong in the program. It actually is a fractional code to find the smallest value. So actually it's finding minimum, and there's something wrong in the code. So let's actually look at it. For this kind of problem, you actually first look at which is wrong. A0 assigned to minimum, I equals 1, I increased. So this I increase usually need to go after everything because you started from 1. You actually increase later and less than n. Okay, while I less than n is, you need to go to n plus n minus 1. So actually you need to move it over here, okay? And if the n, okay, so this one is wrong, okay? This I increase is wrong. Okay. Maneli, are you okay?
Yeah.
So that's finding minimum. So how about, so you need to keep in mind the algorithm, okay? Now 1 is 1 okay or not? One okay or not? Can you change I to 1? So it started from, change to the leaders, it started from 0, and it increase starting from array 1. Yeah, that's actually okay. So let's go up to I equals n minus 1. So you increase I to n minus 1. You get it down. So this one, n minus 1 work okay. And it go up, it's still less than n minus 1. So you increase to n, then you fail. So this one cannot work. Is that okay? You go all the way to n minus 1, it still be working. And then you want the loop to stop, but it won't stop if you are n minus 1. Right here, you are n minus 1, it doesn't stop. So you go up to here, you try n, I actually is n, actually n minus 1, it passed. But you increase to n, when you go to n, this one, it actually fail. So you cannot do that. But it is okay?
Yeah.
How about 2? 2 okay or not? Move the I plus to button. Is that okay or not?
Yes.
Yes, this one okay. So 1 wrong, 2 okay. How about 3? 3 to change it to the I less than equals n. That okay or not? 3, you change this one to less than equals n. Is that okay?
No.
Because you just check up to I increase to n minus 1. It is okay. Then it go up, it passed, so it increased to n. N already tried again, this one is wrong. Okay, so only 2 only, okay? Number 17. Number 17, Helen. Helen, did I call you or no?
I just did like
Okay, then Xavier. Number 17, they are A, B, C, D, E, F, okay, A, B, C, D problem, but right here, okay, assuming that the measure had not been exited, which assertion is true at the end of every execution of the while loop? So when you run the while loop, and then you haven't get out of the loop, so what is true when you haven't get out of the loop? Okay.
Wait, Dr. Cho, I'm sorry. I didn't get called.
You didn't get call. Okay.
No, I didn't.
So you 17 is okay.
Yeah, sorry.
So here you have a match problem. You have two array and n and m, two number. Okay.
Mm.
And the two number are the number of the two array. Okay, that's okay. And then you try to go to see if you matched. So you have the two index. And then while you are in the loop, okay, let me move up a little bit. While in the loop, A, B, C, D, E, which one is correct?
I said C is correct.
C is correct.
Mhm.
So this one actually, when it's still within the loop, okay, so you have an index. If the index is the same, you return true already, okay? So you keep going, and if the V index less than W index, then V index increase. So basically, you started from this V index and Q index are P, Q, two index. One looking for V, one looking for W.
Right.
And every time you will go for actually the smaller one will move. Okay, smaller one will
Mhm.
move. And then they compare if they are equal. Not equal, they will move the smaller one. Okay.
Yeah. I'm
And
sorry.
then, yeah.
I think I changed my answer to A because it's in the loop, so it can equal N. It'll just end.
Yeah, so basically this one you actually, if you still in the loop, you do not have the common value up to the index -1, right?
Right.
And then that's actually had no common value. You're still in the loop, actually no common value. So no common value, everything is the same. Actually up to B index -1, up to B index. Here you don't have, this one don't have the -1, right?
Mhm.
At the end of each execution, okay? At the end of
Yeah.
each execution, actually not including the index. And then this number need to be less than or equal to n. That's actually true, right?
Right.
-1, actually. These are the number of the index. So when you're still in the loop, Vi need to be less than n. Can it be equal? No, if equal, it will get out.
I feel like at the end of the loop it could be equal though, because like if V index increased
Yeah,
and then it
but
got to the
actually,
end of the loop.
at the end of each execution of the while loop, yeah, okay, it can be equal. Okay, let's assume that it can be equal. So then the answer is 8. That's what
Yeah.
you say.
Yeah.
Okay, so this E is done. E cannot be n minus m-1. Okay.
Yeah.
So this V index need to have a -1. So actually D is done. B is done. So the last one difference, this one is the n and m. Okay, so this one actually the answer is A. Let's look at the answer by the book. Okay. The answer by the book, this one is actually number 17. And 17 is A. Yes, 17 is A. Okay.
Yeah.
So it's possible still at the end of each iteration. Actually, the key word is this at the end of each iteration. Okay. You may finish the loop. you may finish the loop, okay? It's actually may finish the loop. So equal n is possible. Index equals n is possible, okay? But the data up to index is actually not common. Okay, number 18, let me have Xavier, okay? I bypass Helen's right now, Xavier number 18. 18 will book, okay, and then there's a book array. Okay, and suppose book list, whatever you actually, every book you do that change status. Okay, so change status is a function for the Boolean value of the change status, checkout status, right? So which one?
I think B.
B. Each book in the book list will have the checkout status change as intended. Let's see, your book actually had a checkout and then the book check status. Okay, so you have array and then it's called booklet. And then array booklet, you get every book and every book got changed this. Yes, so I think this one is B, you will actually change this. Let's look at A. The book list array will remain unchanged. No, it will be changed. Null pointer exception. Null pointer exception happen only when your booklet have null. So the booklet had null. Okay, it's actually initialized. Okay, so you cannot have the exception. You already say it's initialized. A runtime error occurs when it is impossible to modify object using enhanced for loop. No, this one is okay. Enhanced for loop, you cannot do delete object. Okay, but if you don't delete object or insert object, that actually is okay. A logic error, okay, there's no logic error. So this one answer is B. Okay. Number 19 and 20, okay, we do have a bingo card. This one for Helen, okay? So there's a declaration of bingo card and constructor for bingo card. And then you would be, which one would be replacement for the declaration of bingo card? So bingo card is a bingo card is a class. So you want to declare an array of bingo card.
I would say D.
Okay, you say D, okay. And then A and E done because they are integer array that of course wrong, right?
Same with B because it's
And
like
B, you have integer right here is done. Okay, now it actually is a bingo card of 20 or bingo card of the number of players. And you want which one? You want the number of players.
Wait, no, I'm sorry. Probably 20 then.
Bingo card is a object. They are 20 random digit.
Uh-huh. Oh, okay. I'm
Yeah,
sorry.
but actually we are talking about an array of bingo card. So program to declare array of bingo card, the array has a number of player elements. So basically it should be the number of players.
Yeah, okay.
Okay, actually it should be this one,
D.
D. Okay.
Yes.
Not bad to look at it again, okay? Not bad. Don't rush, don't rush. This one, this kind of things, you have to exactly know which one it is, okay? So no rush is okay. Number 20, let me have Banelli. Banelli, it actually has, which one is the replacement for the constructor for bingo card? Can you do, is it one okay or not?
Yes.
One, I would say no. 2, I would say no. 3, I think okay. So why 1 is no? Okay, this one very crucial. Why 1 is no? Anyone know? So no, no, yes. Why 1 is no? This one is very crucial. I think I would like to discuss.
Is it because it's a for each loop?
Yeah, because it's for each loop, but why for each loop doesn't work here?
Because
It's related to for each loop, yes, but why for each loop doesn't work here?
I thought for each loop's made like a copy.
No. How about Elaine, do you know? I say one is not correct, but why 1 is not correct? Can you tell me?
Is 1 wrong because
Mm. I want everyone to discuss because I want you to think deeply, okay? Mhm.
by using like the new bingo card, would it like or like sorry, because it's like
I would say I'll give you everyone a hint, okay? You try to understand it. But the problem comes from this card variable. What is card variable? I say it's wrong.
Is it because card is like a reference to the like card object in players? And so now we're just assigning the reference to something new, but we're not changing the object in players.
But what do we change?
We're just changing where the reference is pointing to.
This one is a local variable. The problem is it is a local variable. So what happens is that you do have a player array, right? And this player array, every single one from 0, 1, 2, 3, this every one is a reference. Okay, is a reference. So you need an object you will be added to here. Now the problem is basically when you do for each loop have a variable card. It's just like I in the for loop. This is a variable, but this variable is pointing to an object. So basically, there is a variable, it pointing to this object, right? There's no problem when you get started, that's right. But when you create a new object, it actually create a new object and it pointing to there. So it actually cut this one and then pointing to the new object in the heap. So the pointer of the array had not been updated. Does that make sense?
Yeah.
Okay. Xavier, is that okay?
Yeah.
And this one is different. This one is actually for each loop I from 0 to the player the length, right? So it actually say player I equals a new object. Player I equals a new object. That is correct. Your array reference got changed. But this one is car is a local variable. It doesn't get changed. Okay. So we would like to discuss in more detail. Okay. 20, okay, 21. Let me have, oh, okay, here you have 2 algorithms. So last time, who is the last time? Last time is Xavier, right? So this one, let's go to Elaine. So there are 2 algorithms, and then which statement is wrong? So you need to understand what algorithm 1 do and what algorithm 2 do. So first you tell me what algorithm want to do.
Algorithm 1, first
Hmm.
it first like splits the number of cards in half,
Split the number of cards in half and
then they like alternate the cards from each half.
不会. So 0 go to 0. Lower half of the first one go into 1. The second one here go to, let me see. No, I'm sorry. This is second half come to here, okay, and then this one will go to this. This one go to here. Okay, so the effect is that you divide it into two decks. And you kind of shuffle, 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 shuffle. Okay?
Yeah.
Is that
And
okay?
then yeah.
Second,
then algorithm-
second one, you actually generate a random number J from there. Okay, and you actually shuffle J to K. Okay. So repeatedly generate a number from here until Ji contain the card that's not marked as empty. So you kind of have I from here, and then you copy it to shuffle K. K is the number. So basically, you are actually have an array. You are going to assign card to certain location called K. Okay, you're going to shuffle a card, okay, and where do you get? You actually get a random number from a card. Then once your J got picked, you kind of set it to empty. And the J card will be assigned to the K location. So basically, this one is to shuffle the whole thing over using random pick. Okay, now these two algorithms, let's actually analyze it to which statement is not correct.
A is true
A is true.
because it's like it won't generate all the possible deck.
Yeah, because why?
Because there's like a pattern to how it's shuffled, so it's like
It has a pattern to
Like-
shuffle, but say let's assume that there is a card at the 0. This card at the 0 go to 0, go to 0, go to 0, no matter how many shuffle you get.
yeah.
Enable move. The bottom card also always go to the bottom. So this one is true because it won't get some. Number two, B for algorithm to determine the last element shuffled require average number of card code to get it true or not.
I think it's true because like you need to generate
There are
random-
only one card left.
yeah.
And this one card is actually 1 over n times. Okay? So that's actually true. C algorithm to lead to more permutation than the A1. That's also true. Okay? In terms of runtime, algorithm is more efficient. D is wrong. D actually algorithm 2 is shuffle better, but algorithm 2 take more time because each time is 1, 2, up to n. That's actually n times n plus 1 time. Okay? F algorithm 1 repeats several times, but it may return to the original state. Yes, that's true. You continue 4 times, 5 times, you go back to the original state. Is that okay?
Yes.
One actually not really shuffle, and after a few shuffle, the one will go back to its original setting. Okay, this one actually a little bit more difficult. Any question on this one?
No.
No. Next one, number 22. Okay, this one go to, let me see, second one, Helen. You have a shuffle program. The method does not work as intended. Which one is wrong?
I think it should be B
B.
because it starts at like the number of cards and that'll be out of bounds.
Yeah, because here you have the +1 that will out of bound. Okay, you want the +1, so basically you need to use the -1. Okay,
Right.
so the answer is B. Yes, correct. Number, let me see, 23. Let me have Melanie 23. Which statement will cause error? There's a string list, and then it's going to add something. So when it adds something, here's string list, add something. Which one add something will be wrong?
E.
E is wrong. Why E is wrong? A is actually a string. Okay. B is also a string. Okay. C is also a string. Okay. D is a string plus H, still a string. Yes. E is wrong because you have integer plus integer will end up with integer. It's auto unboxing. So here, this one, this add is not adding string. Okay, so E is wrong. It's okay. 24, let me have Xavier 24, Xavier. 257601. Which of the following statement will not cause error? Which one no error?
C.
Hmm?
And C.
B, you cannot add the 14 point. B, of course, wrong, right?
All the other ones like
Uh,
are index 6, which isn't in the
Yeah, as I say, only add, you can do the last one that had the index 6. Okay, only insertion had that. Okay, we talk about it, right? Only insertion you can do index 6. Other can go only up to n-1. Okay. Number 25, let me have 11, 25. Here is insert a list with an element. Okay. So this one, when you get out of the while loop, your element should be bigger than the list that greater equal to list that get I. So
Okay.
the number is the 4 and you have a 5, then you will stop. So this one, when
Okay.
you actually go for it, when you insert it, where will you insert the data? This one actually, when you insert the data, you from big one to small one. Okay.
Okay.
So here, let's see, actually, assume the element list, which statement is true. This one actually is sort of in decreasing order, yes. So it will work as intended, I think so. Okay, which one you pick?
I was thinking D, cause yeah, cause doesn't that element have to be greater than the other values for it to work?
Have to greater than other value?
Or like to where, yeah, like the element has to be greater than like the like value in the index.
If the list actually is empty, so if the list is empty, okay, let's assume that the list is empty. So you get 0 will not have value. So you cannot compare. So this one is under actually a assumption that list cannot be empty. If fail if the element is greater than the first one or the smaller than the last one. I think it's greater than smaller than the last one. Smaller than last one, I think will work. This one, I believe that it, well, based on this different data, I think it will actually intended for all value is okay. It will only fail only when the list is empty. Okay, let's actually check the 25, okay? Check the 25 HD, okay, I'm sorry, 25 HD. 25, if fail when the element is smaller than the last one, and work for other case. Is smaller than the last one. While loop, let me see, if you have a 5, 4, 3, 2, and we get a 1 coming in, okay, let's assume the actually the element is 1. So the 1 compared with the index started from 0, you get an index of 0. You increased. So that go to the n minus 1. So when index equals n minus 1, you compare with the element of n plus 1. It is smaller. You actually, you're smaller, your index increase, you insert there, that actually is okay. That actually is still okay. I think this one's still okay. I think this one fail only when the list is empty. Because when your list is empty, you try to get 0, actually you get nothing, okay? Am I correct?
Okay. Yeah.
Okay, when you have a index of 0, you try to get index of 0, you will actually get nothing. You will get exception. Index out of bounds. So when the list is empty, it actually doesn't work. As for you are smaller than the last element, you actually every time you try to compare with a small number, if you finish with the last one, you're smaller than last one, while it actually is smaller than the last one. You actually do, when you get out, it will be greater equals it. So if you are smaller, say right now you are one, you never get someone smaller than you will pass over, and then you add at the end. This one actually work, okay? This one actually work. I don't see that it doesn't work. Okay. Any other anyone see it differently or? So this one I'll say the answer is A. It work for intended for everybody, but with the underlying question or the list cannot be empty. Okay.
Okay.
So here, if we say that the list contain values sorted in descending order, that's assuming that they already some value. If there are already some value, then A is correct. It actually work for all intended value. So if the value is smaller than the last one, if you are smaller than last one, every time you compare with a certain index, you will be smaller because you are smaller than even the last one. And then our last one, you will increase to the list n the size. And when you go to list size, you insert it at the list size. So that actually is correct, right? Actually correct. I don't see that there when you are smaller, it doesn't work. I don't see that. So the answer is A. Okay. Given the underlying assumption that the data already been sorted, so it's not empty by this line. Okay, given the fact that here it actually said, but when it is empty, it will fail. So I think the precondition still not clear. It should say that the list is not empty. Okay. So this one is A for me. Any question?
No.
Okay, then 26. Let me have Helen, 26.
For 26, I said A.
Okay, this one is tracing the condition and then you will get it, right? So this one, nothing, not too much. So let's look at 26. It's A. Okay, you're correct. So basically, this one, nothing special. You just do whatever mechanical operation to figure out what would be added. Okay. 27 and 28, you based on coin and purse. So coin right here, okay. And purse, okay, purse class right there. And purse has many coin. Okay, that's the key things. Okay, for Banani 27, you try to get total. How do you calculate the total? Total is a purse class function. Purse class has an array list of coin, and you want to get total. Okay. So when you want to get total, which one is correct? A is definitely wrong because there is no I, okay? B, you see coin, you get value. This one doesn't return a coin, it return a value, integer, so this is wrong. C, you try to get I again, is it wrong? B, I think it's okay. And let's look at E. Oh, D is wrong. I mean, sorry. D, you actually coins that get value. Coin cannot get value. It's wrong. So actually, E is correct. Okay. But then it's okay. A is wrong because I there's no I available. So this A and C both drop. This for each loop you do not need to get value is not getting a coin. So this is wrong. This one coins is array list. You cannot get value. Is actually wrong. So answer is E. Okay. But then it's okay.
Yeah.
Okay. 28. Let me have Xavier 28. 28, you have 1, 2, 3. So tell me one correct or wrong, two correct or right. Okay. So which one the correct implementation for find match? So you have a find, you have a coin, and each one of the coin you do, okay, match the A coin. So that equals, get name that equals, get value that equals. Which one?
Mm. 1 and 2 work, but 3 doesn't because equals compares like not a double.
These are not objects, so there is no equals function that you can compare. Yes, the answer is 1, 2. Okay. So D 1, 2. 29, let me have 11. Two-dimensional array, 8 by 10. With integer value, which is a perfect square.
For this one, I
8 by
think 1
1.
works,
Mm,
and then 2, 2 doesn't work.
why?
Or, wait, no, sorry, 2 does work,
Why?
because for 2, it starts off with like the same thing, and then it assigns each row like the same value through the R times R. So
So
basically,
this one, basically you have 0, 0, 0, 0, 0, 0, 0, okay, 8 by 10, right?
yeah,
This one you would have 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, 2, 2. So totally you would have 8 rows, right?
yeah.
Okay. Let's assume that I don't know what is a perfect square, but let's assume that's a perfect square. So how about 3? 3 wrong where? Where does 3 get wrong?
For 3, mm, 3 doesn't work Because it's doing the columns first and then the rows? Or,
No, column first is okay.
oh, okay.
Column major, that's called column major. That's nothing wrong.
Okay.
Anyone know? Xavier, do you know? Hello, Xavier, hear me?
Yeah.
29, where you go wrong? 3. 29 is option 3. Where it go wrong? How about Heather, do you know?
R wasn't declared yet, so you can't just
Yes,
choose it
R hasn't declared yet. R is available in the inner for loop. It's R using inner for loop variable and outside is wrong. Column go first is okay, but R is not okay. R you haven't declared it, you cannot use it. Okay, so here you should put 0, that is actually fine. Okay, you cannot use a variable R. Is that okay? Number 30, let me have, okay, go to Elaine. So number 30, let me have Helen, number 30.
For 30, I'd said E.
So this one, it is column major. So you do column from small to big. So it's going this way. But row from large to big to small. So it's going this way. Okay, it's going this way. You actually column major, but row from large to small, right? So with this one, you actually would do 9, 0, 2, 1. You say the fifth element printed should be. Okay. Fifth element printed. It actually started from the last row. And the row greater than column. Oh, here it actually also had a row greater than column. Okay, no. So I'm wrong. Let me clean it. So you have 1, 3, 5, 2, 4, 6, 0, 7, 8, 9, 10, 11. And this one is actually row 0, 1, 2, 3, column 0, 1, 2. Your column is starting from 0. You actually need to go for row greater than column. Row greater than column, you starting from this one, row 3 greater than column. So everything, your column starting from 0, your row greater than column. So you actually should go from the last row. So you actually get started from here. Row greater than column, I'm sorry. Row greater than column. Your column is 0. So your row greater than, it come from big to small. So you actually do 9, 0, 2. So when it is row equal column, you don't. Then you do 10, 7. So the fifth number is 7. Okay. But 4, you don't put it. Is that okay?
Yeah.
Okay. This one you need to analyze the coding. Okay. I did not look at this row greater than column first time, but you have to look at it. Any question on this one?
No.
No, let's continue. 31. 31, let me have Vanelli 31. you have a matrix, you alter C. I think C actually is a number. So what you do is that you roll from the first one to the last one, you call them from C plus 1. So let's assume that you have 1, 3, 5, 7, 2, 4, 6, 8, and then 3, 5, 7, 9. Your C right now set to order of 1. Here's 1. You will do starting from C plus 1, starting from this one. Then is the column value copy to here. So actually 5, 5, 6, 7. And then this one will give you 7, 8, 9. This is 9. So at the end, you could get this one, 8. Okay? But then himself, okay?
Yeah.
Got to, this one, you got to understand it, go all the way to it, okay? So number 32, JB, you're 32.
A.
You have this metric, and how will you work?
Like numcos is like the x component, like
So
the
here you
length
have
of
the
the x component.
2, right? You have a 2. So your column, you go for every column. Your row number, so that 2 set to 2. I'm sorry, your row 2 set to 2. So you say 8?
Yeah.
Okay. The whole row 2 set to 2. Okay. That's actually okay. That's the idea that it will do. 33, let me go back to Elen 33. So it actually is a metric and see what happened. Okay, so it's a 2 by 2 metric. And then swap IJ. So you need to look at the swap IJ. IJ, you have A, B, C, D. Okay, so your metric A, B, so your IJ will be swapped with its symmetry location. Okay, IJ will be swapped with its symmetry location. Actually, J and the I. CD is a row. Okay, so let's assume you have 2, 6, 4, 3. Remember, this is J, this is I. So let's assume that you have this one 0, 0 will swap with 1, 1, right? So basically 0, 0 swap with 1, 1, you become 3 and 2. And you have 0, 1. 0, 1 will swap with size minus 1. Minus 1, that actually would be swapped with 0. And I is 0. So 0, 1 will swap with 0, 1. It will stay with itself. So it still be 6. And then this one is 1, 0. Will swap with 1, 0 as well. So it will swap the diagonal 1 and the value on the corner one would stay. So this one, I think is B. Okay. This one is 33. 33 is B, okay? Is it okay? You
Yeah.
enter the program, actually, it do some swap, but it's actually IJ swap with the matrix symmetric of JI. So what you would do is that you need to enter the 0, 0 will swap with 1, 1. 1, 1 will swap with 0, 0. Okay, 1, 1 will swap with 0, 0. And then 0, 1 will swap with 0, 1, so no change. 1, 0 will swap with 1, 0. Okay? So the corner one, no change. Diagonal one got swap. Any question? Is that okay?
Yes.
34, 34, we have. Okay, 34, who should be 34? 30, this one I said David. Okay, this one go back to 11, 34. So 34, you have this. And then you are kind of, you kind of copy this one to here, copy this one to here, and then the last row becomes 0, right? So this one does not work as intended. What should you do? So it actually do for I and J starting from C is the number you do. So when you say 1, you copy from the next row to there. The copy part is okay. So insert 0 with the rightmost. So this one automatically will go with, okay? So, but there is something wrong. Something wrong is the column C. No, you actually what? This one should be column major, right?
Yes.
So this one should be outside. And this one should be inside, right?
Yeah.
So the answer is, so there's a 1, 2, 3. No change. I think it's no change is wrong. Change 9, 10, and 11 too. So let's see. Here you actually 9 is outside. 9 is for AB row. So you actually should copy every column. But not work as intended. This one you have C plus 1. So every row you actually start from C. Okay. You do C starting from C+1 to copy. That's actually this one probably okay. This one you starting from C, your +1 go over there. Then this one you actually need to end up -1 there because you will be out of bound. Okay, so 2 is okay. And then if you change it from C to the -1, this one should be also okay. So 1, 2, okay, and then 3, changing J starting from the length -1. You backward traverse, so until you are C. No, this one you would actually, you will overwrite the previous solution. So this one is wrong, it cannot. So you have to, 1, 2 is okay. This one is actually 34, 34 is D, 1, 2. I think it's 1, 2, okay? 34 is D, 1, 2. 1 is okay. So this one actually you have a 2, 1, 0, A, 4, 3, 9, 3, 2, 0, 0, 0. So your C is here. You started from C, but you had to copy from this one. You need to have a -1 because it's a window of 2. Okay, so that will work. Or you started from C +1, you copy to the previous one. Then it's okay. This one also okay. This one is wrong because you actually copy backward. So right here, this one you copy to here, but this one's value already been overwritten. So that is wrong. Okay. Any question?
No.
35. So you see the array problem usually very hard. Okay. 35 go to Helen. Helen.
For 35, I said D.
So what happened if you D means 1 and 3.
Mhm.
So when you do the element in row 2 and column 2 is star. So it's actually checking you that actually which combination after the operation would evaluate the value to be true, right?
Yeah.
So this one, row 2 and column 2, you have, that's assume you have A star, 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 star. This one is the first answer. Second answer is diagonal star. Third answer is column 2 only. Okay, let's look at which one would work. So which one is true? You actually say counter equals 0. So you actually pass a star over, okay? And then in the same size, your column is the column that you pass in. Okay. The counter increase, if the counter equals size, then it will be true. And then you will go every row. Your row number, okay, you go over the row number, and then if everything is the same symbol, then it's true. So as long as you have a row or column that has the star, so the row 2, column 2, as long as you have both row and column or just column, that is okay because this one is OR. Okay. So the answer is D, correct. But this one to check in the whole row or whole column to have the symbol or not.
Yep.
Number 36, let me have Benelli 36. 36 is a swap problem. What do you swap? You swap your array or your symmetry location, okay? So this one you swap met2, okay? So Benelli, what does it mean by swap met2? Benelli, are you okay? Hi, Benelli, hear me?
It's
Swap met2 means you only swap the row 2. So row 2 swap to its symmetric location. So your row 0 and row 1 no change. This one become 9056. Okay. And who is this one? I think D is the answer. Okay. Is that okay?
Yeah.
Must work on it, okay? This one cannot just depending on me to explain what it is for you. 37, let me have Xavier. Xavier, I won't help you now, okay? Tell me what is the answer and why. So you want to replace all the negative number in the matrix with 0. What will you do?
check every place in the 2D array.
So you 1 okay or not?
It works.
2 okay or not?
I think it also works.
No. 2 I think okay. 3 okay or not? Xavier, 3.
No.
Why not? Three not okay. Why?
Because it uses
So anyone who knows that 3 is not okay.
Because it's primitive.
No, because it's still a local variable. You get a value to element, but the element nothing to do with the array. Is that okay?
Yep.
It is a local
Yeah, that's
variable.
what-
It
yeah.
actually nothing to do with it. So it says 1, 2, this one, okay? It's a local variable. When you do for I equal 0, I is a variable. For each string that is a separate string that has nothing to do with the array element, okay? You just get the value from the array. That's actually not the array itself. So 38 go back to 11. Here you have two-dimensional rainfall. Okay, whatever. A two-dimensional rainfall. So you actually try to sum up your array for the average rainfall. So which one is correct? Which one is not correct?
A is incorrect because they do total divided by 13 times 32.
This number
Which
is
is
too
not-
big. Okay. This
Yeah,
number
it's
too-
wrong.
I'm too okay or not?
2 is okay, I think.
Why?
Because it loops through like all the days. And it, like the division of the 365 is correct.
So why starting from 1 here?
Because it starts from January.
But what happened to the rainfall 0? What happened to this?
They contain the 0.0 or
Yeah, they contain 0.0. So what happened? This one is 13 times 32. So basically you have row 0 and column 0, row 0 right here, column 0 right here. This actually put with 0. So those with 0 actually okay. It doesn't hurt your data. And you have every single one, maybe some of them just 28 days. You also have the 0.0. So that also no problem. You have quite many dummy cell. Okay. You have quite many dummy cell, but those dummy cell contribute 0. It doesn't change the average value. So this one actually okay. This one you go for every month and go for every day. This actually working now as the same. So both okay. 2 and 3 is okay.
yeah.
So this one is E, both okay. Number 39, let me have Helen, 39. So here we do have a point that has xy, and then we have the so-called function that will change negative for the point xy. Okay, point metric. Replace every that has at least one negative coordinates with 0.00. Okay. So which one is correct?
I said 1 is correct because
One is correct. Okay. How about 2?
Yep. 2, the prerequisites didn't say that point matrix has the same number of rows as columns,
That's assume it is.
but yeah, then it's correct.
Then it's correct. How about 3?
3 is also correct.
Three is correct. So 3 is correct. Okay. 3 here, P is again is a local variable.
Right.
So why 3 right now is correct, not incorrect?
Because P is like a reference to the like actual object
So
of
you
the
have
actual
the
array.
2-dimensional array. Okay, so if it is a primitive data, then you say you get the value. So right here you get the value to the value right here. That's so this is 10. And then you update this cell to 7. Then this is wrong because the variable is a local variable. But right now it's a reference. It is a reference, so here it actually get an object. And this object is pointing by P as well, and P updated the matrix object also got updated. So this one is also correct. So this one, 1, 2, 3. Okay. Does that
Yep.
make sense?
Yeah.
So be careful about this kind of for each loop, okay? For each loop, sometimes it's local variable, sometimes it's local reference, and reference may still point it back to the matrix. Okay, so this is 3 is very important issue. Okay, sometimes you got forward. Number 40. Number 40, let me have Vanelli, number 40. So there's a pixel method, set red, okay? So there's a method called remove red in the picture. You go through every row and column and then set red value to 0. So each pixel has a set red with a value. So 1, 2, 3, which one is okay? This one, you pick the pixel and then set red to be 0. I think it's okay. This one is pixel, so this set red, I think it's also okay. This one not setting red is wrong. So this one's 1, 2, D, okay? Does that make sense? Lily, are you okay?
Yeah.
Number 40. 40, you have matrix. Then you do this. This actually, you do mirror side. You actually copy this one to here, okay? That's example 1. So this one also mirror, you copy it to here, okay? So now that's you want to do mirror in the middle vertically, okay? You want to do mirror in the middle vertically. So here you have the width, you have the number row, and then you have every of your row and your width go half, and you want to copy different column with the width minus column minus 1 minus column. So I think the value is this one, your symmetric location, okay? Is that okay? This one is actually this last one actually copy from right to left. That actually is wrong. Okay? So the answer is D for this one. Is that okay? Xavier, is that okay?
Yeah.
This one missing -1. Oh, I'm sorry. Actually, no, D is wrong. D copy from right to the left. Actually, it should be C. Okay, C copy left to right. C is correct. D is wrong. This one missing -1. This one missing -1, and this one missing -1. A and B missing -1. They are both down. C is actually copy from left to right. D actually copy from right to left. So D is wrong. Okay? And then this one copy. No, I'm sorry. This row and column need to be in the right. So actually E. No, this one swap the row and column. That's actually wrong. So the answer I think is C, okay? This one missing -1, this one missing -1. This one you copy from the right to the left. It's also wrong. So the answer is C. It's okay? JB, it's okay?
Yeah.
Number 42. Number 42, you have the for loop for row from 1 to the length, column from 0 to row. Okay, let's look at this one. This one actually, you actually should draw something like this. So your row from 1 to the end, column from 0 less than row. So you're actually doing lower triangle. Okay, so row triangle, your row and column copy. So your row copy to here, you do symmetric copy. From lower triangle to upper triangle. So let's assume you have 1, 2, 3, 4, 5, 6, 7, 8, 9. You will copy for 4, 7, 8. So you got 1, 4, 7, 4, 5, so you got 8. Okay? This is actually a check of upper lower triangle. You check it, it's actually copy from lower triangle to upper triangle. So I say lower triangle, it actually is when you have an array. It tell you actually from 1 to n, so not including 0, not including 0, your first row, not included. So it actually is from here to here. Okay? And then it's a row column to column row, row column to column row is copying like this. Okay? Everybody okay on this one? Last problem, okay, last problem, let me have Helen. Here's a XY game, okay, the tic-tac-toe game. And then correct replacement for the two-string method. You check for the two-string method, you want to create a two-string method that actually printing like this. Okay?
Yeah. I said E because none of the other options did like the bars, right?
Okay, I think E, okay. Let's see other ones error, okay? One, you started with this. You actually, no, this one actually need to be outside, right?
Right.
So that's actually wrong because you duplicate the bar. This one, you have this one outside, but this one inside, that's actually also wrong, okay?
Yep.
And then 3, actually, this one here, okay, but this one outside the loop, totally outside, this is also wrong. This one, wait, this one actually for loop, not getting the right parenthesis, right? So
Yeah,
E, yes, so E correct, okay? Good job. Any questions so far?
No.
I think we're quite late. We don't have time to for the FRQ anymore, okay? Wish you work on it, okay? Must practice yourself. If you don't practice, this kind of discussion has not much help for you, okay? Good night and see you. Good night. Bye-bye.
Thank you.
Bye. Thank you.
Good night. Thank you.
Bye-bye.